Hello. So I'm going to discuss so I'm thinking about 50 problems in dynamics. So this is problem one. I try to teach dynamics. Um, Not that I'm trying to teach dynamics through these problems, but I'm trying to explain how to solve dynamics problems um, in these videos. And at some point, I'm probably going to document all together and put it all together. So it's good for first, second year engineering students and those who have physics, mechanics, and those who are taking physics mechanics in their last year of high school. The first problem I'm discussing now is I have these two objects. They're thrown vertically. They're absolutely similar objects in every possible sense, same mass, same geometry. So they are only the difference is they are being thrown vertically, thrown up vertically, with some time between them. So object A is thrown into the space or thrown into the air, and then object B a few seconds later, say, is thrown into the air. And it says a question is discuss and determine the velocities of the two objects when they pass each other. So the two objects are exactly the same. So you're being asked to discuss and determine the velocities of the two objects. I guess it's not a bad idea if I could cover the solution part. Next time I'll do that. So the object A is thrown to the air. So let's say it follows this path. It goes up, it reaches to its maximum height, and then it starts going back. So the object B is thrown sometime later after A, but with the same initial velocity. So you can imagine that if I ask you, for example, when A is going to be, let's only think about object A. If I throw this object into the air, if I ask you this, forget about B for a moment. If I ask you what time A is going to be at height h, you're going to say that object A, assuming it has sufficient initial velocity to reach to h, and assuming that h is smaller than the maximum height, object A in fact is going to be at height h at two times, once on his way up and once on his way back to the ground. So if you write down the equation we have for the height of object A, it's a simple equation you have, from your basic physics or high school physics or basic university physics, college physics. YA is YA0, initial height plus initial velocity multiplying time plus half acceleration times squared. And you're going to say, all right, so if I set, because I asked you what time this object A is going to be at height h, you're going to say, all right, so I'm going to set YA equal to h. And you even understand that intuitively, object A is going to be at height h at two times. And you're going to see it mathematically here, because if I set my coordinate system to be on the ground, YA0 at time 0 is equal to 0. And this is my initial velocity, and the object is only accelerate because of gravity, and gravitational acceleration points down, so the acceleration is equal to minus g, and then you set YA equal to h. Therefore, you expect this equation, as you would expect, to give you two times. a smaller time, a larger time. So because you know that for a smaller time is the time it takes for object A to reach to this height, and the larger time is the time that it takes for I to go back to this height on his way back to the ground. And that's why we have a quadratic equation, and that's what it means to have a quadratic equation. As we develop this equation, and you know that, all right, so object B is exactly like object A. So every equation we write for object A is the same as for object B. So object A is at height h at 2 times, on his way up and on his way back. And given that the two objects are exactly similar, you could say right from here that when object A is at height h on his way back, in fact object B is at height h on his way up, right? Because the exact same equations apply to both objects. And you need this height because the problem is asking you the velocities of the two objects when they pass each other. So whatever height this is the height that both objects A and B are in fact going through in that particular time. And you do expect physically that for A to be on his way back to the ground and for B to be on his way up. Alright, so the time you have figured that you can in fact use this equation and compute the time. Compute the time it takes for A to get to height h, and compute the time for B to get to this height h. Okay, so once you have time, you know that for this problem, the only thing you need to write down is VA is equal to VA0 minus GTA. And it's the same for object B. So, and the only unknown, because the initial velocities are the same, you can replace VA0 and VB0 with V0. The only unknown is time. So, once you use this equation to compute the time, quadratic equation, to get a little smaller time, you get a larger time or bigger time or longer time is the time that it takes for A to go through this curve, through this path, and B is to go from here to here, the smaller time. Once you have these two times, you can plug in the two times into equation 2, and then you can compute the velocities of A and B as they pass each other. So I leave this the last part to you. So, and you should get VA half GT and down and BB half GT up. Okay. So now you have this problem, you know the solution to this problem. Also think about what happens if the two objects were not similar. You shouldn't have a fundamental problem solving with that one too. Because the only difference would be, alright, height again is the same if the two objects were not the same, right? So you should ask yourself, alright, do we have the same initial velocity or not? Right. Because if you look at this equation, and this one, these two kinematic equations, well, the parameters appear in these two equations are like initial velocity and gravitational acceleration. So I'll leave that problem to you. Thanks for paying attention.